Hello, students. Imagine that the soil is a comprehensive organism. We apply various materials to the soil in the process of planting crops. How does the soil absorb and digest it? Will it get indigestion? Will it be ill like human beings? Today, let's learn about the soil colloid for evaluating and adjusting the absorption performance of soil. The ways of soil material absorption and retention can be divided into 5 types. Among them, ion exchange absorption is the most important way for soil to keep and supply fertilizer. Ions are charged to produce exchange. It means that there are also charged substances in the soil. What substance is that? That's soil colloid. Soil colloid refers to the soil particles whose length, width, and height are between 1 and 1000 nanometers, and at least one direction is within this range. Soil colloid structure can be divided into particle core, potential determining ion layer, and compensation ion layer from inside to outside. 1. Particle core is also called colloidal core. It is the core part of soil colloid, which is composed of clay minerals or humus. 2. Determination of potential ion layer. Charged ions are generated due to the dissociation of molecules on the surface of the particle core. This layer is called the potential determining ion layer. Generally speaking, the potential determining ion layer is dominated by negative electricity. 3. Compensation ion layer. Because of the existence of the potential determining ion layer, it absorbs the ions with opposite charge in the dispersion medium, and the opposite ion layer is called the compensation ion layer. Charge opposite, according to the gravity, it can be divided into inactive compensation ion layer and the diffusion ion layer. Soil colloids can be divided into 3 types according to the composition of particle cores. 1. Inorganic colloid. Colloids are tiny clay particles which mainly include iron, aluminum, silicon, oxides, and their hydrous oxides. In clay minerals such as secondary aluminosilicate. 2. Organic colloid. Colloidal particles are all kinds of soil humus and a small amount of lignin, protein, cellulose, etc. Its activity is stronger than inorganic colloids, but its quantity is relatively small. 3. Organic-inorganic complex. Mineral colloids and organic colloids in the soil combine with each other to form organic-inorganic composite colloids. Organic colloids and inorganic colloids in soil rarely exist alone, and most of them are combined to form composite colloids. These compound colloids are the main material basis for forming a good soil structure. Soil colloid is the most active part of soil solid phase, which has great influence on soil physical and chemical properties and soil fertility because the main soil colloids have the following characteristics. 1. It has huge specific surface area and surface energy. The energy generated by the existence of the surface is called surface energy. The smaller the soil particles are, the larger the specific surface area is. The larger the specific surface energy is, and the stronger the ability to absorb ions is. On the contrary, the smaller the specific surface area, the worse the absorption capacity. 2. It is charged. Soil is generally negatively charged. 3. It has certain cohesiveness and dispersibility. There are 2 forms of soil colloid. Colloidal solution formed by dispersion colloidal particles in soil medium is called soil. Colloidal particles gather together to form flocculent precipitate, which is called gel, and certain conditions, they can be transferred into each other. When the colloid is in gel state, it is beneficial to form soil aggregate structure. The characteristics of soil colloid determine that it has a greater influence on soil absorption performance. Okay, that's it for this class. See you.